This video, I am discussing 2025 KSET Mathematical Science, Linear Algebra questions. In that, from which questions you will get grace marks. Also, I will discuss, see the full video, you will get for which questions you get grace marks. These are official key answers. Question number 71, linear algebra. The dimension of the subspace W is equal to matrix is given Aij such that Aij is equal to 0, I is even. Of all 10 into 10 real matrices is, that means it is in the form of A11, A12, A13 and so on, A110, 110. Here A21, I0 means 0, 0, 0 and so on. This is 0 and so on. A9, 9, A91, A92, A93 and so on, A9 and 9, 10. Here 0, 0, because I is 10, 1 means 0 and so on 0. Like this, order of this matrix is 10 into 10. Here 1, 2, 3, 5 rows are 0. That means we know that dimension of matrix is dimension of Aij matrix of order m into n. If this its dimension is matrix of order m into n, its dimension is m into n. Here 5 rows are 0, therefore its dimension is half of that. That means 2. 50, 100 by 2, that means 50. Simple question. Next, which of the following statement not true? The intersection of any two subspace of a vector space is a subspace. This is true statement. The intersection of an arbitrary collection of subspace of a vector space is subspace. This is also true. The union of two subspace of a vector space necessarily, keyword necessarily, is a subspace. This is false. You can take a small example and remove. For example, 1, 0, 0, 1. If you take the union of this, we get 1, 1. But 1, 1 does not belongs to any of this. Therefore, this is false. The union of two subspace is a subspace if and only if one is contained in other. This is true statement. Therefore, option correct right answer for this question is option 3. Next, the condition for ABC such that vector alpha is equal to ABC is a linear combination of vectors 1, -3, 2 and 2 minus 1, 1. Simple. They given simple equation. Let's take any of vector v1 or v2. Substitute these values. You get 0. That is the right option. Take any one option. 1 minus of minus plus 3 plus 2. It is 6 not equal to 0. Therefore, this option fails. Next, 1 minus 3 into minus 3 plus. That means this is minus pi into 2. 1 plus 9 minus 10. This is 0. 10 minus 10 is 0. Simple. If in another way, take a linear combination and solve. That is also right. This is also right. This is shortcut. This is option 2 is the right answer. This holds. No need to check other options. If you check other options also, you won't get 0. I checked already. That's why this is the right answer. Next, if W1 and W2, this is the repeated question. Repeated questions from PYQs. If W1 and W2 are two finite dimensional subspace of vector space V over F, then W1 plus dimension of W1 plus dimension of W2 is equal to, we know that dimension of W1 plus W2 is equal to formula for dimension of W1 plus dimension of W2 minus dimension of W1 intersection W2. Here dimension of W1, W2 is given. If we take this into left side, this becomes positive sign. That means the dimension of W1 plus W2 plus dimension of W1 intersection W2. Yes, this is option A is the right answer. Next, this is also a repeated question from PYQs. Let linear transformation given. Let T from U to V be a linear transformation between finite dimensional vector spaces, then rank-nullity theorem or Sylvester's law. Rank-nullity theorem. Nullity theorem. By using rank-nullity theorem, that means the dimension of U. Dimension of U means the dimension of domain is equal to rank of transformation plus nullity of transformation. Dimension of U is equal to rank of T plus nullity of T is in fourth option. Fourth option is the right answer. Next, the rank of matrix is, see, I solved this. Apply R1 to R3. That means replace R1 by R3. We get A as like this. Next, apply R2 dash is equal to R2 minus 4R1. R3 dash is equal to R3 minus 2R1 and R3 dash R4 dash R4 dash R4 dash is equal to R4 minus R1. We get rank of this is 3. That means in option, this is fourth option is right. If you want, write down all. Next question. Pause and write down if you want. Next, the solution of system of equations. The given system of equation x plus 2y minus z is equal to 3. Just write down augmented matrix A, augmented B, this is matrix A, this is matrix B. Augmented matrix for this is here. By backward substitution, we get x is equal to minus 1, y is equal to 4, z is equal to 4. X is equal to minus 1, y is equal to 4, z is equal to 4. Option 4 is the right answer for this question. Same procedure as followed in the above question. By backward substitution, you get x, y, z values. Next, which of the following statement is not true? Not true. They are asking for not true statement. The eigenvalues of a real symmetric matrix are real. This is true. Spectrum of matrix. In a spectrum of matrix, this is real. Here 0, 0, 0, 0. Imaginary, symmetric, skew symmetric. All are here. All are positive. You know that. Next, the eigenvalues of real skew symmetric. See, yeah, this is symmetric means A is equal to A transpose. This is symmetric. Next, the eigenvalues of skew symmetric matrix are either purely imaginary or 0. That means A is equal to minus A transpose or A transpose is equal to minus A. In this case, we get purely imaginary or 0 eigenvalues. This is also true. The eigenvalues of Hermitian matrix are imaginary. Here, see, A is equal to A theta. That means A conjugate or transpose. A conjugate. Here we get real eigenvalues. Real eigenvalues. Therefore, this is false. Next, the eigenvalues of skew Hermitian matrix are either purely imaginary or 0. That means A is equal to minus A theta. In this case, we get imaginary or 0 eigenvalues. This is also true. Not true statement is option 3. Right answer is option 3. Next, 79th question. Which of the following statement is true? Here they are asking true statement. See, if 0 is an eigenvalue of a matrix, then A is singular. This is true. Simple question. Simple option. If 0 is eigenvalue of A, then A is invertible. This is false because A is invertible if and only if all eigenvalues are non-zero. This is false. Similar matrices have different eigenvalues. This is false. Similar matrices have same eigenvalues. If lambda is an eigenvalue of here 0 is an eigenvalue of a matrix, then A is non-singular. They given non-singular. If 0 is an eigenvalue, it becomes singular. Here they given non-singular. Therefore, this is false. Next, if lambda is an eigenvalue of non-singular matrix, here non-singular matrix A, then 1 by lambda is eigenvalue of A inverse. This is true. Simple question. This is true. They are asking true statement. Therefore, option 4 is the right answer. Next, eigenvectors of matrix 1, 0, 0, minus 1 are. See, matrix is 1, 0, 0, minus 1. Eigenvalues are 1, minus 1. To find eigenvectors corresponding to lambda is equal to 1, the A here Ax is equal to lambda x. If you take Ax lambda x in this side, we get lambda Ax minus lambda x is equal to 0. That means A minus lambda I into x is equal to 0. Here lambda is equal to 1 is there. Therefore, A minus I of x is equal to 0. X here, vectors here, x1, x2. I am taking vectors x1, x2. Therefore, 0. If we put lambda is equal to 1 in this, that means 1 minus 1 means 0, 0, 0, minus 1, minus 1, minus 2. X1, x2, 0, 0. 2x2 is equal to 0, x2 is equal to 0. Here, let take x1 is equal to, we get here pivotal element. This is non-pivotal. Therefore, x1 is equal to k. X1 belongs to f. X1 belongs to field. K is not equal to 0. Therefore, eigenvector corresponding to lambda is equal to 1 is x is equal to x1, x2, k 0. Take k outside, 1, 0. This is for lambda is equal to 1. Similarly, we can find lambda is equal to eigenvector corresponding to lambda is equal to minus 1. Vectors are these 0, 1 is the vector for lambda equal to minus 1. Therefore, 1, 0, 1, 0, 0, 1. This is the right answer. Next, this is they change small here. They make change in small basis same in 2024 question. They change small terms in t of xy. This is also a repeated question. See, let a transformation let t from r square to r square and t of xy is equal to 2y 3x minus y for all xy belongs to r square, then matrix representation of t relative to the basis 1, 3, 2, 5 is, see, if we put basis 1, 3, we get 6, 0, and 2, 5, we get 10, 0. If we write in linear combination using this, we get 6, 0 is equal to alpha plus 2 beta, 3 alpha plus 5 beta. If we solve this, we get beta is equal to 18, alpha is equal to minus 30. Next, similarly, from using second, we get alpha is equal to minus 48, beta is equal to 29. Minus 30, minus 30, 18, minus 30, 18, minus 48, 29. That means option C is the right answer for this question. If you want, note down all steps. Next, if minus 1, 2, 2 are eigenvalues of a matrix A of order 3 into 3, then eigenvalues of A cube are just cube of these eigenvalues. That means minus 1, 8, 8. This is the right answer. So A x is equal to lambda x, then A raised to m of x is equal to lambda raised to m of x. This is the result. That's why this is true. Option 1 is the right answer for that question. If the square matrix A of order 3 has eigenvalues 2, square of order matrix 3, that means 2, we don't know this, 0, 0, 0, 2, 0, 0, 0, 8, like this. Then trace of A is simply sum of diagonal element. Trace is sum of trace of A is equal to 2 plus 2 plus 8 is equal to 10, 12. Answer is 12. Option 2 is the right answer. Next, the minimal polynomial of the matrix 3, minus 1, 0, 0, 2, 0, 1, minus 1, 2. See, first find characteristic polynomial of this. Characteristic polynomial of A of x is, characteristic polynomial of A is lambda minus 2 whole square, lambda minus 3. Now find minimal polynomial. To check minimal polynomial for this, first take eigenvalue 3a minus 3i. That means this is not equal to 0. Next, a minus 2i. This is also not equal to 0. Product of these two, we get 0. That therefore minimal polynomial of A of x, minimal polynomial of A is, minimal polynomial of A is t minus 2 into t minus 3. This is the right answer. Next, 85th question. If x and y are orthogonal vectors in inner product space, then norm of xy square is equal to, right, xy is, norm of xy is x plus y. This is x plus y, x plus y. We get norm of x square. This is y square, because here x comma y is equal to 0 and y comma x, dot product of x into y and y into x, here 0. That therefore We get this. And option A is the right answer for this question. Next, the quadratic form of Q of xy corresponding to the symmetric matrix 5 minus 3 minus 3 8 is 2 into 2 matrix here xy. That means quadratic form means x transpose Q matrix. This is matrix and x. And this type here xy. That means x here is x comma y. Simple. X comma y. X transpose means rows into column. 5 minus 3 minus 3 8. Now x means x comma y. Simple is equal to, see, put this as it is. This is 1 into 2, 2 into 2. This is 2 into 1. First solve this. We get 1 into 2. That means x 5x minus 3y comma minus 3x plus 8y. Now x comma xy. Solve this. This is 1 into 2. This is 2 into 1. We get 1 into 1 matrix. That means 5x minus 3y into x plus minus 3x plus 8y into y. Solve this. 5x square minus 3xy minus 3xy plus 8y square. That means 5x square minus 6xy plus 8y square. And option 2 is the right answer. This is the right answer for this question. Simple question. See, the orthonormal basis for the vector 1, 1 and 2, 1 in R square R. This question can be solved using Gram-Schmidt orthonormalization process. That means, see, it is a process used to find an orthonormal basis for finite dimensional inner product space. Finite dimensional inner product space given a basis, of V. Here this is V1, V2, basis V1, V2 given. Let B is equal to V1, V2. Next, let us take W1 is equal to V1. That means 1, 1. Find W1. Next, 2. Second step is W2 is equal to V2 minus inner product into W1 divided by norm of W1 square. Here W1 is equal to V1 is equal to 1, 1. Norm of this is square root of 1, 1, 1 square plus 1 square means root 2. Find W1 divided by norm of W1 means 1 by 1. W1 is 1, 1. That means 1 by root 2, 1 by root 2. Next, W2 is V2 minus inner product of V2 W1 into W2 divided by norm of W1 square. If we solve this, we get 1 by root 2 minus 1 by root 2. Procedure is there. See, In option 1 by 2, 1 by 2, 1 by root 2 minus 1 by root 2. This is the right answer for this question. Next, see, a real quadratic form Q of x is equal to x transpose A of x is negative definite. See, is negative definite if and only if the given if and only if all eigenvalues of A are non-negative. That means positive eigenvalues. This option, this means positive or zero. Non-negative means positive or zero. Next, all eigenvalues are negative. Next, all eigenvalues of A are positive. All eigenvalues of A are, this is negative is the right answer. C, all other option also. All eigenvalues are positive. This is also same. This is also same. This is meaning of this and this option is same. They given same option. Therefore, they may give this question as a grace mark. Grace marks for this question. Next, A has positive as well as negative eigenvalues. Indefinite form. Indefinite. In this case, indefinite. Therefore, if a real quadratic form Q of x is equal to x transpose A x is negative definite if and only if all the eigenvalues of A are negative. This is true. Next, 89th question. For what value of M vector M3 1 is the linear vectors of 3 2 1 E1 is equal to basis 3 2 1 and 2 1 0. The given C, simple question. M3 1 linear combination, they are telling linear combination 3 2 1 alpha x plus beta y. This type 3 2 1. Here see other options. 2, this is 3 2 1 2 1, this is 2 1 2 1